you are given this chemical reaction. First part of the question: what is the theoretical yield of C6H5Br when 30 grams of C6H6 reacts with 65 grams of Br2? Pause the video and first try it out yourself. For easy calculation, I will consider the formula mass. The atomic masses of carbon is 12 grams per mole, hydrogen 1 gram per mole, and bromine 80 grams per mole. The question asks you to calculate the theoretical yield of this product, and you are using 30 grams of benzene. So you have 30 grams of that, and you're reacting it with 65 grams of Br2, and you have 65 grams of this. When it says theoretical yield, you know that is the amount you expect from this balanced equation. According to the balanced equation, the amount of product you should get. But before going into that, you have to determine what's going to be your limiting reactant. You can determine the limiting reactant either by comparing the amount of product you get with each reactant, or you can compare the reactants to each other and determine the limiting reactant. So you can use whatever the way that you feel comfortable. Here I'm going for comparing the amount of product given by each reactant. First, I'm going to take C6H6. I have 30 grams of C6H6, and I'm going to find how much product I'm going to get with that. So what I need to find is grams of C6H5Br. Now I cannot do it straight with grams. First I have to convert this into moles of C6H6, and then I have to relate it to the moles of C6H5Br. From that I can go to the mass of C6H5Br. Molar mass of C6H6 is going to be 78 grams per mole, meaning you can use this as a conversion factor. 78 grams of benzene is 1 mole, or you can use it as 1 mole is 78 grams. To get rid of this grams unit, I need to use this form of the conversion factor. So I'm going to write down 78 grams of C6H6 is 1 mole of C6H6. I got rid of the grams terms. Now I have things in moles. Next, I need to convert these moles to relate these moles to the moles of C6H5Br. To do that, I have to go to the balanced equation. This equation doesn't need any more balancing because it is balanced itself. According to this balanced equation, 1 mole of benzene produce 1 mole of bromobenzene. I can use that also as a conversion factor. 1 mole of benzene gives 1 mole of bromobenzene, or you can have 1 mole C6H5Br, giving 1 mole, related to 1 mole of benzene. Now I need to get rid of mole C6H6. So between these two conversion factors, which one should I go for? I need to go for this. I'm going to plug that in. 1 mole of benzene giving 1 mole of bromobenzene. I can get rid of mole benzene. Next, I need to convert moles of bromobenzene to grams. To do that, you need the molar mass of bromobenzene. Molar mass of bromobenzene is 157 grams per mole. You can use this as 157 grams is 1 mole, or 1 mole is 157 grams of bromobenzene. I need to get rid of moles term, so I need a mole term as the denominator. So I have to go for this conversion factor. I'm going to plug that in. 1 mole of C6H5Br is 157 grams. Now do the math. You have to work out these numbers. That is going to be 60.38 grams. That is how much bromobenzene you will get with 30 grams of benzene. Next, you have to calculate how many grams of bromobenzene you will get if you are using 65 grams of bromine. So in the mole map, you follow pretty much the same path, only that you're using 65 grams of bromine here. Convert that to moles of bromine, then relate it to moles of bromobenzene, and then convert it to the grams of bromobenzene. This is 65 grams of Br2. Bromine molar mass is 1 bromine atom is 80. So Br2 is 160 grams per mole. So I'm going to arrange it as 160 grams of Br2 is 1 mole of Br2. This gives me the number of moles of Br2. From the balanced equation, 1 bromine molecule gives or 1 bromine mole give 1 mole of bromobenzene. I need to get rid of this term, so for the denominator I need 1 mole of Br2 giving 1 mole of C6H5Br, and then I need to convert this to the mass, so I'm using this conversion factor again. 1 mole of C6H5Br is 157 grams. That's 63.78 grams. Now between these two answers, which is the smaller quantity? That is this. And the smaller quantity of product was given by 30 grams of benzene. So in this reaction, our benzene is going to be the limiting reactant. And Br2 is the excess reactant. So what is our theoretical yield of bromobenzene? It is this, 60.38 grams. Second part of the question. If the actual yield of bromobenzene is 56.7 grams, what is the percent yield? You get the percent yield by dividing the actual by theoretical into 100. Your actual yield is 56.7 gram, and from the previous calculation your theoretical yield is 60.38 grams. Your percent yield is 93.9%.